Welcome to the second lesson in probability. In this lesson, we'll be learning how to work with the addition and the multiplication rules, and we'll also be learning about mutually exclusive events as well as independent events. Another way of thinking about this lesson is that we will learn to work with three tools. We'll learn how to work with contingency tables, we'll learn how to work with Venn diagrams, learn how to work with tree diagrams. Let's jump right in with an example that uses a table. This table represents data collected by an insurance company as they look at some of their customers. The customers were classified according to two variables, their age and whether or not they had a driving accident in the previous year. Mature customers are those who are at least 25 years old. Young customers are those who are less than 25 years old. Each customer also either had a driving accident or they did not have a driving accident in the previous year. Now, when we look at this table, just these four cells right here in the middle, we can actually read off four probabilities immediately. Now, to get to probabilities, we'll have to work from counts. 250, 200, etc. These are counts of customers that are under study. 250 were both young and had a driving accident in the previous year. 2300 were mature and had no accident during the previous year. This cell is mature and had an accident. This cell is no accident and young. Now, if we want to get to probabilities, we need to divide by the total number of customers. We could do that by simply summing up these values in these four cells, and we'll see that that comes out to be 3,750. Of course, we could have summed these two subtotals to get the same value. This is the number of young customers. This is the number of mature customers. In the same way, there's yet a third way to get the total number of customers. We could get a subtotal for those who had an accident. There are 450 of them. And a subtotal for those who had no accident. There are 3,300 of those. So whether you sum these two, or the four in the middle, you'll get the total number of customers, 3,750. These four cells in the middle allow us to get counts and probabilities of the intersection of two events. By that I mean, this one, for instance, is the event that a customer is young together with the event that the customer had an accident. 250 both had an accident and were young drivers. The probability of choosing such a customer is 250 divided by 3,750. The way to think about it is that the columns and the rows represent events. These points in here, these cells, are the intersection of those events. So Y and A, M and A, Y and the complement of A, M and the complement of A. These lead directly to four probabilities. The probability that a driver had an accident and is young is found by intersecting the young column and the accident row. So the young column and the accident row together occurs here in our table. There are 250 of those customers, and we divide by the total number of customers, 3,750. Now we can do the same with the other three interior cells, accident and mature, no accident and young, no accident and mature, to obtain these probabilities. Now something similar happens in what's known as the marginal distributions. These are the bottom row and the rightmost column. The 450 and 3,300 are the counts of those customers that had an accident and those who didn't. Likewise, the 1250 and the 2500 are those customers who are either young or were mature. This leads directly to probabilities of young, mature, and accident or no accident. Here are our probabilities then. The 450 goes with accident, 3300 with no accident, 1250 for young, and 2500 for mature. Each of those is divided by 3750, which is the total number of customers. All of these and probabilities come from the interior of the table because these cells represent the intersection of a column and a row. Likewise, the marginal distributions will give us probabilities for events that do not appear compound. They are simply A or A complement, Y or M. In summary, the simple events, A complement, Y, and M, those probabilities we can get directly from the marginal distributions. The intersections, or the AND probabilities, A and Y, A and M, A complement and Y, A complement and M, all of those come from the interior of the table. Now, that allows us to get everything in this list that doesn't involve an OR. How do we do those?